So good morning to all. Today we are going to see the topic from induction motor. The topic is types of single phase induction motor. So these are the types of single phase induction motor. They are classified as the first one will be a split phase induction motor. Second one is a shaded pole induction motor. Third one is a capacitor-start induction motor. Fourth one will be capacitor-start, capacitor-run induction motor. And the last one will be permanent capacitor induction motor. So now we are going to see one by one. The first one will be split phase induction motor. The split phase induction motor is can be explained with the help of the diagram shown in the next slide. So before that we see the theory portions. Uh, as we all know that the induction motor having a stator and rotor, there are two windings will be there, and in this type of split phase induction motor, there are two windings will be there in the stator side. So one winding we call as a main winding. So another winding we call as a auxiliary winding. We call as a auxiliary winding. In some cases, the main winding will be called as a running winding. The auxiliary winding we call as the starting winding. Right, and one more switch which is connected in series to the auxiliary winding. So centrifugal switch is connected in series to the auxiliary winding. In this construction, auxiliary winding will be in a highly resistive winding. The main winding will be in a highly inductive windings. The auxiliary windings are having a few turns with a small diameters. So what is the main purpose of this auxiliary winding is to create the space difference between the two flexes flex produced by the main winding and rotor windings. So this is the diagram of the split phase motor. As we told that this is the main winding, so this is the auxiliary winding. So and also we said that there is a one switch is connected series to the auxiliary winding. So this auxiliary winding is in a resistive nature, it is an inductive nature. So since the supply voltage V is supplied to the both the windings, so both the windings will be producing the flexes. So since this auxiliary winding is a resistive nature, so it will follow the input voltage. Since this main winding is an inductive nature, it lacks the voltage by the its current is lacks the voltage. That is what mentioned in the IM. The current flow through the main winding will be IM. The current flow through the auxiliary winding will be mentioned as IA. So adding of these two winding will get two currents will get a resultant current. Right. So that is what mentioned here. As we told that IM is the current flowing through the main winding, IA is the current flowing through the auxiliary winding. Right. Next one is a shaded pole induction motor. So as we compare to the other types, it is a completely different versions of the construction will be there in this type of induction motor, shaded pole motor. What are the different construction means? So here we doesn't require any auxiliary winding. So what is the difference here made means in this stator we are using a salient pole type of stator which we are using. The rotor is the same as of screw cage type. Here the construction difference will be made in the stator side. Here your stator will be poles will be divided into two parts. So one we call as a shaded pole, another one is we call as a unshaded parts. For so in this your stator will be cutting into unequal cutted the poles will be created with uneven distances. There are two poles will be there. So one poles will be placed with the copper rings. So some of the poles will not be covered with the copper rings. So which pole is covered with the copper ring we call as a shaded part. So the remaining part will be called as an unshaded parts. So this copper ring is a highly inductive nature. So this is a diagram of the shaded pole induction motor. As I told that this is a rotor side This is the stator side. We have a poles 1 and 2, 3, 4. In this pole, we can see that uneven cuts in this. So this is one pole, and this is another pole. You can see that in all the stator poles, so there is a copper wine ring will be placed here. So the red color mark in this we call as a copper rings. So this portion we call as a shaded portion. The remaining portion will be unshaded portions, right? So once you are given the supply to the stator side, since we are having a coil in this, so as we you know that according to the Lenz's law, so any current flows through the coil, it will opposes the flex induce. So that is what mentioned here. According to the Lenz's law, current flowing through the coil, it is in opposite nature. The flux produced in this coil will be opposes the main flux. So as we all know that we in stator side we have two poles. So the main flux produced will be opposes by this shaded ring portions, right? So when both the fluxes will be in the same direction it will be opposes the main flux. If you suppose it is in same direction means the flux will be increased. So next one is a capacitor-start induction motor. So it is an advanced version of the split phase induction motor. So what is the main disadvantage of split phase is that it produces the low torque. To overcome this, so a series capacitor is connected in this auxiliary winding. So that is we call as a capacitor-start induction motor. So the diagram shows the capacitor-start induction motor. As we have told that there is a series capacitor is connected to the auxiliary winding. This capacitor is not permanently connected for it is not connected for continuous operations. When the speed is reaches 75 to 80 percentage, this auxiliary switches will be open and it will cut at this auxiliary winding. So as this phasor diagram indicates that the current flow through the IM will be main winding, IA will be auxiliary winding. So since we told that this auxiliary winding is a highly inductive nature, so it lacks the voltage by I. So when a current flow through this winding, so main winding and auxiliary winding, since we are having a capacitor in this, it will give the additional amount of energy in this induction side. So it will have more energies in this to it will produce more torque to provide a initial high torque. And capacitor-start capacitor and induction motor. In this we have two capacitors are connected in parallel series with the auxiliary winding. So one is we call as a starting capacitor, another one is we call as a running capacitor. So it is a average representation is that it is the main winding, this is the auxiliary winding. So in auxiliary winding, two capacitors are connected parallel in series with the auxiliary winding. These two capacitors are connected in parallel in series with the auxiliary winding. In say, starting capacitor is a series. There is a switch is connected in series with this. So when the rotor speed is reaches 75 to 80 percent, this centrifugal switches will be open and it will cut the starting torque. So only we are connecting the running capacitor in the to the auxiliary winding. So initially we need some high torque. For that purpose only we are adding the two capacitors. Since these two capacitors are connected in parallel, so we have a equivalent capacitor that will be connected to this auxiliary winding during the starting. So when it is reaches the 75 to 80 percentage of maximum speed means it will cut the centrifugal switch. So only running capacitor will be connected to the circuit. So that is what I mentioned in this statements. So mostly we are using in the air conditioners and refrigerators, compressor, these kind of motors will be there. The last one will be permanent capacitor induction motor. So in this case, a permanent capacitor will be connected to the auxiliary winding, which valve will be having a low capacitance. So initially it will produce some starting torque for this operation. So once it is reaches the maximum speed, it is running to the normal operation conditions. Thank you all.